Welcome to week 1 of the fungalmaterials.org workshop. My name is Jason Padvorak, and I'm honored and glad to have you here. If you are watching this video after the workshop has ended, no worries, you can follow along at your own pace. The lessons will all be listed at fungalmaterials.org/2018-workshop-1. At any point, comment out and join the discussion in our Facebook group by heading over to fungalmaterials.org/group. Feel free to share questions, comments, feedback, and especially pictures of what you are making. Today, we're going to go over how the workshop will run, briefly cover what fungal materials are, and talk about why they're so awesome. We'll have a quick preview of the next lesson, and then go over today's homework assignment. If you follow through the 8 weeks of this workshop and do the homework assignments, at the end you'll have a basic mycology lab set up in your kitchen. You'll understand how to grow fungi for material purposes and also for food. And most excitingly, you will be growing and creating things from fungi that you can use in your everyday life. Let's dive right in. Every week, there will be a lesson. I'll upload a video much like this one that covers some aspect of the theory of fungal materials and also teaches you a specific skill for growing your own fungal materials. This is a hands-on workshop, even though it's online. We're going to start with some basic skills for cultivating fungi, and by the end, you will be making your own objects. Each Friday at 4 p.m. Pacific Standard Time, I will do a live question and answer session at the Facebook group at facebook.com/groups/fungalmaterials. Of course, you can ask questions and leave comments at any time, and I and others will be there for you. But it's nice to have live conversations sometimes too. And homework. I've mentioned this several times already. It's really important if you want to learn this and to put it into practice yourself to follow along with the homework. Now we're ready. What are fungal materials? When people think of fungi, what first comes to mind is mushrooms. That's the most visible part of fungi most of the time, and it's the part that we typically use for food and for medicine. Fungi also have growth below the surface, though, much like the roots of plants or trees. Fungi send the mycelia, long, thin threads of it, into the substrate they are growing on, into the food that they're consuming. Mycelia contain chitin, the same hard material that forms insect exoskeletons. Chitin is very similar to keratin, the stuff that makes our fingernails. Mycelia can bind and knit their substrates together quite tightly. If you've ever seen or read Gulliver's Travels, you may remember the Lilliputians, the tiny little people that at one point trap Gulliver and bind him tightly with their thin little ropes. But because they use so many ropes, even though they're so thin and fragile individually, they make him completely immobilized. Mycelia form meshes and webs that function much the same. Each individual tiny mycelium is not much on its own, but when they interlock and spread and surround and go through the substrate, they can completely transform it. So when we're creating fungal materials, first we prepare a substrate. This will be the food for the fungus, and our choice of substrate will significantly shape the properties of the final material. Then we add the fungi. There are various ways to inoculate substrate. Most of what we will be doing is taking little pieces of mycelia, sometimes growing on grains, sometimes growing in a liquid nutrient solution, and we will add this to the substrate. We won't often deal with fungal spores themselves. Then, after the mycelia have grown to the point that we want, we will harvest the material. It must be dry before being used, and sometimes we will heat treat it to kill the fungus and make sure that there will be no more fungal growth. There are a variety of ways to process the materials after this point, but we will talk more about that later. Okay, why are we doing all this? Why are we trying to make stuff out of fungi? Because fungal materials are awesome, that's why. First, fungi can take things that are otherwise just waste or suitable for compost pile and turn them into things that are useful for us in day-to-day life. We can turn straw into a lamp, or we can turn various things into structural materials. We can take sawdust and turn it into bricks. Related to that, fungal materials fit beautifully into local economies and ecologies. Because fungal materials can be created with a large variety of agricultural products, they can be created with locally grown materials. And because they're biodegradable, when we're done with the things that we created with fungi, they can just go into the compost pile to create fertile soil instead of going to a landfill to create toxic waste. And if you're talking toxins, fungi are all natural. Unless you add toxins to the things you produce with fungi, they'll be completely toxin-free. Through most of human history, the production of clothing, structures, and all the other physical things that we need has been incredibly labor-intensive. We lacked the technology and the knowledge to make things easily. The Industrial Revolution happened, and suddenly we had the technology and knowledge to make things with incredible ease. Machines could make things for us. But now we are beginning to see the cost of that kind of centralized, extremely powerful technology, like the disruption of local economies, the rise of things like sweatshops, and the environmental and health devastation that comes from the enormous use of harmful chemicals and the enormous use of energy that occurs with industrialized processes. Creating things with fungal materials is a beautiful example of something called appropriate tech. We are using knowledge and science and technology to make our lives easier, but in a way that's human scale. Ordinary people can easily make these materials in their kitchen, or their shed, or their garage. We're capturing the benefits that technology can give us, but we're doing away with many of the problems that we pay for with high tech. If we want a sustainable future on this planet for us and our children, the name of the game is not high tech. The name of the game is appropriate tech. And fungal materials are naturally customizable. By changing the substrates and the growth conditions and how we process them, we can make things that are hard like bricks or like lumber. We can make things that are flexible but tough like cowhide, or thin and supple like textiles. We can make things that are soft and spongy like rubber. We can make things like cork. We can make all kinds of different things by simply varying the recipes that we use to make them, the techniques to process them. We can transform almost any starting materials, quotes, waste products, into almost whatever kind of output we're looking for. Like I mentioned earlier, the materials are non-toxic unless you add the toxins yourself. These materials are hydrophobic. They repel water because the chitin in mycelia naturally is hydrophobic. They're not completely waterproof, but they will shed water very well. If you've ever tried to burn a rotten log, you know that materials infiltrated by fungal mycelia are naturally fire retardant. This is especially important if we're making clothing or structural elements or household items, and that's most of what we'll be creating with fungal materials anyway. These materials can be very lightweight. The fibrous mesh nature of the mycelia is very efficient at providing strength with very little mass. And that mesh nature also makes fungal materials very good at insulating. They're good for thermal insulation and they're good for sound insulation. Because we are growing these materials, we can simply put them into a mold and grow them in any shape we like. If you wanted to make something out of wood, you'd have to mill it or carve it to the shape that you wanted. But with fungal materials, we don't have to. We just grow them in the shape that we want. And because these are naturally grown materials, they have an innate beauty to them. As we learn more about working with fungi to create materials, we're going to learn more and more tricks for harnessing that natural beauty and combining it with our designs. Fungal materials solve a lot of problems for us. Pollution problems, environmental problems, economic problems, and they create new canvases for us to experiment with, to create new kinds of clothing, new kinds of structures, and new kinds of art. We often divide human history into ages: the Stone Age, the Bronze Age, the Iron Age, and now the Industrial Age. The physical substances that we use for our tools, clothing, and shelter, and how we produce all that, defines the kind of world that we create and live in. As we're seeing more and more and more the problems with the Industrial Age, it's time for a new age. We are now creating the foundation for the Fungal Age. In the next lesson, we're going to talk about fungal leathers and kombucha leather, and we'll get you started growing your own grain spawn. This grain spawn is what you will use to seed your substrates to start the fungi growing. This is a foundational skill, and you'll be ready for it next week. All right, it's time for homework. Let me encourage you again to do the homework. It's simple and inexpensive, and you can do this yourself. If you run into any difficulties, let me know, post about it in the group, and we will help you figure it out. First, there are some readings for this lesson available at fungalmaterials.org/2018-workshop-1. Go to that page and then click on Lesson 1. Every time there's a lesson, it will be listed on that page. There's a PDF on that page about setting up your lab, and it has a list of supplies. Start to assemble the things that you will need. If you can get a pressure cooker, or if you already have one, that will make your work easier, but it's not required. What you do need is a liquid culture syringe. That's what you'll start your fungi growing from. There's a list of vendors linked to from the workshop lesson on the website. The last part of your homework assignment is to make some air port lids. You will need these next week to make your jars of grain spawn. I will be uploading a video demonstrating how to make air port lids on the workshop lesson 1 page. Well, that's it for this week. I will see you around on the Facebook group and in next week's lesson. Take care.